Hello everyone. Now we'll discuss the question number 10. In circuit 1 and circuit 2 shown in figure, R1 is 1 ohm, R2 is 2 ohm, R3 is 3 ohm, P1, P2 are the power dissipations in circuit 1 and circuit 2 when the switches S1, S2 are open conditions respectively. Q1, Q2 are the power dissipations in circuit 1 and circuit 2 when switch S1 and S2 are in closed conditions respectively. Now you need to identify the situation. So now you first to draw the circuit diagrams. R1 is equal to given 1 ohm, R1 is 1 ohm, R2 is given 2 ohm, R3 value is given 3 ohm. According to the circuit diagram, you can see R1, R2, R3. First, here R1 is 1 ohm. It is connected to the circuit like this. R2 is 2 ohm and R3 value is given 3 ohm. Here one more R1 by 2 is connected, that value is 1 by 2 ohm. The switch is open. After that only I am writing this. It is connected to like this it is connected. Okay, if you see this, these two resistors are in series. We'll get Rs is equal to 2 plus 3, 5 ohm will get. Now this 1 by 2 ohm and this both are parallel. So if you calculate that parallel resistors, we'll get R parallel 1 by parallel is equal to 1 by 5 plus you can get the 1 by 2. You can write R 1 by 2. That value is how much? 1 by 2 will get 2. This value is 11 divided by the 5. So I can write resistance in parallel is 5 divided by the 11 ohm. Next, this Rp is in series with this. So R effective value can be written as, let us consider this R effective value is R only. R is equal to 1 plus 5 by 11. If you calculate that, 16 by 11 ohm is R1 unit. R1 is this. R1 is this. Okay. Now, next case, what they have given, if S2 is open, two or three resistor will not be there, but all three resistors are in parallel only. You do it here in figure 2. In figure 2, we can observe that 1 ohm, 2 ohm, 3 ohm is connected parallel to each other. Now 1 by R2 value can be written as 1 by 1 plus 1 by 2 plus 1 by 3. So you can observe that 6 plus 3 plus 2 whole divided by the 6. 9 plus 2, 11 by 6. So you can write R2 value is equal to 11 divided by the 6 ohm. R2 value is this. Now according to options, if you see that when voltage of 6 volt is connected between A and B, P1 is less than P2. How can you say that P1 is less than P2? If V is same, power P is equal to V square by R. Nothing but P is inversely proportional to R. Now we can see R1 is 16 by 11. This one is 11 by 6. 16 by 11 and 11 by 6. Which one is more here? See whether it is 11 by, sorry, here reverse I wrote. R2 value is equal to 6 by 11 ohm. Now you can see R1 is greater than R2. R1 is greater than R2. So obviously P1 is less than P2 will get. So first option is correct option only. Next, if I is same current is passing through the circuit, P is equal to, you can add I square R. Now you can observe that P is directly proportional to R. As R1 is greater than R2, we can see that P1 is greater than P2. So second option is that P1 is greater than P2 is correct. Again, when voltage 6 volt connected between A and B in circuit 1, Q1 is greater than P1. So now you have to connect to this again. Now you can see this is R1 is 1 ohm. Again, it is connected to the short circuited wire. We can see here R2 is 2 ohm. R3 value is 3 ohm. And here one more resistor R1 by 2, that value is 1 by 2 ohm is there. The whole thing is connected to the battery. Whenever whole thing is connected to the battery, we can observe that already here whatever current is this current will go like this. It will be distributed like this. Okay, it is short circuited. It is connected between the 2 points direct wire. Now this already you have calculated. That value you can see R1 is equal, RP is equal to 5 by 11. 5 by 11 is there, no, that only. So you can see that R1 dash is equal to 5 by 11 ohm. You can see 5 by 11 ohm. Now again you observe this. If according to question C bit they are asking that when voltage 6 volt connected across the A and B circuit 1 is how much? If V is same, we can say that P is equal to V square by R. Now you can see it is a 5 by 11. This one is a 16 by 11. 5 by 11 and 16 by 11. Obviously R1 is greater than R1 dash. Okay, and you can see RP is inversely proportional to R, no? So from this data we can see that R1 is greater than R dash. So we can write it as R1 is nothing but here P1 less than Q1. P1 is less than Q1. If you observe this, the option is when Q1 is greater than P1. This is correct. When constant current is 2 ampere is connected across A and B in both the circuits, Q2 is less than Q1. Now you have to calculate the last one also. If you see last one, already you have calculated the value of this. So already parallel resistors, that parallel resistors you got like a R1 by R2 is equal to 11 by 6 is there. Okay, R6 by 11. And whenever switch is closed here, you can get the value of this is given that 2R3. What is 2R3? 2 into R3. 2R3. 2R3 value is 6 ohm. The whole thing is connected to the source now. Now you can write 1 by R2 dash is equal to, you can write 11 by 6 plus 1 by 6. You can write 12 by 6. That value is 2. So R2 dash value is 1 by 2. Now again you see that which one is more here. So according to question they are asking that earlier 2 ampere is connected. If 2 ampere is connected, if I is same, power is directly proportional to R. We can see here this value is 0.5, this value is less than 0.5. So we can write R2 dash is greater than R1 dash. Okay, if R2 dash is greater than R1 dash, we can see that Q2 value is that Q2 value is greater than Q1. But if you see these options, they are written Q2 is less than Q1. So this is the wrong answer. According to the given, what we got is options are correct. Options are A, B,